All right, we get going? All right, we're a minute over. So that was everybody's, 1 minute warning. We're going to go ahead and get started. We'll bring everybody else up to speed. But my name is James Hawk from Cradlepoint. My role is Vice President of our sales engineering organization for North America. So when I say sales engineer, does everybody know what that means by a show of hands? Okay, great. So what does a sales engineer do? I'm going to start there with a little advertisement. So we get to spend all of our time in the field with our customers and partners. And our really ask from the business is to understand the technology from a technical point of view, but also a business point of view. So we really sit in the middle between where our products are built and the account managers, or the folks that work on business ROI with our customers and partners. So we sit in really a sweet spot in the middle where we get to geek out with our customers and our partners and get to travel and be across many, many different industries and customer types. So that's what sales engineering is all about. So we wanted to bring to you a conversation today around private cellular networking and how it's evolving and sitting alongside public cellular and Wi-Fi. So by show of hands, who has heard or understands the role of private cellular networking already today? You feel comfortable with PCN. You've heard the term, you understand the differences. Okay, great. Everybody knows what Wi-Fi is, right? All right, so what we're gonna do is we're going to bridge the gap between what you know about Wi-Fi and what you know about public cellular through Verizon, AT&T, T-Mobile, all of those big carrier providers. So what is driving the need for private cellular networking? First of all, why are we even remotely talking about taking something that works at a macro environment on the public carriers and bringing it into the enterprise? There's a couple of things. Explosion of devices is really the one that I call out to start. There are so many devices that are very hard to manage from an enterprise. You think about running a warehouse or a logistics area or a big open air park on the public safety, public sector side of things. That's hard to do when you start seeing so many more proliferation of IoT devices that are out there. It becomes very expensive, very hard to manage on a public cellular network. So you want to bring the best of these two things together. The next one is, what are some of the things that our customers are driving towards? Before we get into what it is, what are some of the things that are driving the conversation behind private cellular networking? It brings a more secure profile than traditional Wi-Fi. So when we talk about securing networks, that's a pretty important topic of conversation with our customers and partners. You talk about control and ease of management. Sometimes it can be difficult when you have, hundreds and thousands of devices that you're trying to manage public carrier SIM cards in each one of those. Okay, think about data plans and everything like that that you would have to manage with a public carrier. So private cellular networking brings some of the benefits of that cellular security control of having that SIM card in a device, but it allows you to manage it more closely and brings an ease of use to the equation. So where can private cellular networking help? If you look at one of the things that we talk about, that we work with from a Cradlepoint perspective with our public carriers, that we run into a lot of that, is that consistent performance. By the nature of public carriers, the way the towers are deployed throughout the infrastructure can sometimes introduce some unpredictability when you're moving through a very highly congested area. If you're a public safety vehicle, for example, or if you have a fixed wireless location that's talking to a public tower, but maybe that tower gets saturated at different parts of the day. So if you're relying on wireless WAN technology and you need that consistent, predictable performance in a defined area, and we'll talk about what those use cases are. Sometimes public or private cellular networking is a great option to take a look at. We talked about security. Think about, we've heard security implications of Wi-Fi for a long time. You know, many of us as network builders are very concerned about securing local area Wi-Fi networks. We haven't heard too many problems with the security of the public cellular networkings. First of all, it's much easier to lock down a connection when you talk about that SIM card is a very specific token that they need to gain access. And then the encryption that's on the public carrier network is a step above, and it's a lot harder to sniff those out of the air and break that encryption versus Wi-Fi. The last thing is a economic model. That sometimes when we work with customers and they have a high density of devices in a confined area, we talked about the data fees. You know, it's not cheap to buy and use public cellular connectivity sometimes. So that the data fees that you have with many devices on a cellular network can sometimes drive the use case. So now that we've talked about Wi-Fi, we've talked about public cellular. Now we're going to talk about how private cellular sits in the middle of those. So we see on the Wi-Fi widespread adoption. It's relatively easy to manage and configure. Everyone has set up most likely a Wi-Fi network in their home and small businesses. And then public cellular, we all use that. The proliferation of 5G. A lot of our customers are going through 5G transformation today, where you have device types that you've had on LTE, but now you're looking at potentially fixed wireless access from a branch perspective. Maybe you're replacing a broadband connection. Maybe you're replacing a fiber connection. Now that you have 5G speeds that could operate in the hundreds of megabits to 1 to 2, maybe even 3 gigabits, depending on where you're at and the infrastructure that's being supported. So this new option that we'll talk about today is where I take the technology that the public carriers are implementing throughout the US, and I take it down to a footprint that is compatible with a enterprise implementation, okay? So these are not easy networks to build up until now. So in the last year or two, as companies started to use cellular in a private context, where they would go out and buy the cellular equipment and install in their own environment, it was very difficult to do. You see at the top right, from a hardware perspective, you had the RAN, the radio access network, okay, the actual infrastructure that's sending the signals out from the tower. You had the evolved packet core, which is really the software that drives packet flow and subscriber management. You know, where are those SIM cards? Who has that SIM card? What are they allowed to do on the network? And then you have a few others, you know, the servers and the networking that it takes to put that all together. That was expensive and very complex to build in the last couple of years. More than likely, those were coming from different vendors, all of them, right? The radio access network was one vendor. The evolved packet core was yet another vendor. The switching and routing infrastructure to carry the traffic was yet another vendor. And as a customer, it was a very difficult undertaking to build a private cellular network by yourself. You think about the real estate that it took to build that. The infrastructure was built for macro networks. It was very hard to find an enterprise built or enterprise designed package of radios that would broadcast the cellular network in a very enterprise friendly fashion, if you will. So, you know, what I want you to take away from this message is over the last couple of years, this wasn't really an option for enterprises because it was very difficult to do. Not impossible, but really it was the larger enterprises that had the money to spend on a team that understood how to do this, that had the wherewithal to design a private cellular network. So we're going to start to break down what it is, so that by the end of this discussion, you can walk away and the goal is really, I understand the role that it's playing now. We're going to talk through some of the use cases and I'm going to understand the components that it takes to build this. So public cellular networking is based for the most part on shared spectrum called CBRS, Citizen Band Radio Service. And that is a public spectrum, brokered by the FCC that allows anyone access to that radio spectrum for your own use. Now, there's different types of those. I'm at the bottom here. So the tier 1 are those that already have access to the CBRS network through legacy agreements. Okay, so maybe they purchased or had access to the CBRS spectrum from a legacy, and now they can continue to use that, but they have dedicated part of that piece of spectrum that is theirs to use. Tier 2 is I'm a customer or I'm an organization and I can go out and purchase a priority pass, a PAL, that gives me the ability to supersede others. That if I want to go out and do a certain amount of bandwidth, I can go buy the right to use that as a priority above others that haven't purchased that. But for the most part, what we see is normally a lot of is the tier 3, and that's the general use. It's brokered by the spectrum allocation service, which we'll talk about. And it really allows customers to jump onto the CBRS spectrum free of use at any time, and the system itself knows who else is using the spectrum in that area, okay? Now, what does it take to build one of these networks? Okay, so what Cradlepoint believes in, if you remember all of those piece parts that it took from different companies that you'd have to go buy, what we've done is taken the complexity out of all of that. So you can go into a CBRS private cellular architecture just through Cradlepoint.
I found this on the web.
Excuse me. But it's an all-in-one, right? You can come in and you can architect everything that you need from a single platform with a single window into how to configure and manage it. Pretty powerful. So that's what we believe in, taking the complexity out of private cellular networking, because we believe it has a great potential to sit in between public cellular and Wi-Fi. Now, public cellular is not going to go away. Wi-Fi is not going away. But we're going to talk through some of the use cases where there's a middle ground that are really, really interesting, that you can pull together some blended architectures where it makes sense. So if you look at, who are we building this for? We're building this for one of the main drivers that we've seen with our customers is the move to lean IT. All of our customers are being asked to do more with less. So we're trying to design products that don't take an entire team to implement, an entire team to architecture, an entire team to manage. So what you'll find here is from a development perspective, we're really looking at ease of use, ease of management, ease of operation, okay? So we're going to go through what each one of these components are, but if you look at the top, you've got the endpoints. Let's start there. So a Cradlepoint endpoint, has everyone seen at least what a Cradlepoint endpoint looks like down at the table? But if you have a chance, stop down, have the team show you one of the devices that we have. But it is an endpoint that does just about everything when we talk about routing, switching, security, and it gives you that gateway not only from your local devices that you're connecting via wired Ethernet, via Wi-Fi wireless, and then it bridges that to a wireless WAN. So I can go to any public carrier. I can go to a private carrier if you're going to build one of those, and that's really the endpoint's function, to give you that gateway from wired Ethernet or Wi-Fi to a cellular signal. That bridge, if you will, and that gives you the ability to then process and secure your traffic right at the edge. We talk about private SIMs. These are very similar to the SIMs that you pull, that you work with within your phone, within what you get from AT&T, Verizon, T-Mobile. That's in your phones right now. It looks very, very similar, but it's just made for the private cellular network that you're building. Okay, so if I had one with me, it just has a Cradlepoint logo on it, but those are very, very similar. It plays the same role. Cellular APs. So very similar to a Wi-Fi AP. Everybody's seen one of those. You know, they're big, little, sit on the ceiling. There's probably a couple somewhere near us. Very similar on the cellular side. So we very simply have designed them to be thought of architecturally just like a Wi-Fi AP. But it would take a cellular access point. So instead of broadcasting Wi-Fi, it's now broadcasting a private cellular signal. Okay? The mobility gateway is really the brains of that operation. It's where the evolved packet core, or really think about it as the brain of the system. So it's where your SIMs are managed. It is where all of the traffic rules, depending on how many APs you have, depending on what applications you're running, the user management. Some users may get access to more bandwidth, et cetera, et cetera. But that mobility gateway is the brain of everything that's happening, that software perspective. Policy from an administration, that's simply as the network builder, you get to decide what users get what level of experience. Very simply, that's where you manage it. And the analytics is very, very simple. It gives you just amount of information, not less, not more, just the right amount of what you need to manage the network. What are users doing on the network? How is the performance? Is it all the security policy that you've put in place? How is it doing? So you're going to pull that through the analytics side of things. Okay, so what does this look like in the real world? Okay, we talked about the components, but what do they really look like? How do they operate with one another? So starting at the very bottom, you have your wired or wireless clients. Okay, think about a laptop. Think about someone's phone. Think about a IoT sensor. Maybe you're in a warehouse and you have a forklift that has a bunch of sensors on it to know where the forklift is in the warehouse, to know how fast it's moving. And all of those sensors are on that forklift, and it needs connectivity to report all of those things so it can know exactly where it is in the ecosystem of that warehouse. That's what we talk about when we talk about wired and wireless clients. Okay, now going up, that's going to speak to that endpoint that you put in the warehouse. So you could have it on, we have implementations where we've put that endpoint directly on the forklift itself, and it moves around with the forklift and creates a little Wi-Fi bubble around that forklift, so that forklift can go anywhere in the warehouse and it has connectivity back over the private cellular network. We go up to the cellular access points. So they're going to be wherever you install them around. Could be on the side of the building, could be on the ceiling, but that's where those endpoints are talking to. Now, the difference here and the key is from the simplest perspective, it's very, very similar to how Wi-Fi works, right? You have your wireless device and it's communicating to a base station somewhere, very similar in private cellular. The key is I can normally have more clients on that access point than I can with Wi-Fi, and I can go larger distances. So if you think about, let's say you have a large room and it takes you 12 to 15 access points from Wi-Fi to build the amount of coverage that I need for wherever that forklift goes. You're more than likely going to be able to do that with 1 or 2 cellular access points. So just think about that. Configuring, cabling 12 to 15 devices, would you rather do that or potentially do 1 or 2? Okay, so you start to see some of the efficiencies that you could get into when you get into a private cellular network. Okay, and then the top is the mobility gateway that we talked about, and that's really where the brains of the system sits. That's where that's where all of the processing happens. That's where all the security policy gets applied. The SIMs are managed, And then it has some sort of external connection, whether that's to carry the traffic going out to the internet or out to NetCloud Manager, which is that Cradlepoint front door that allows you to manage all of this from a single pane of glass. Okay, so why do we build this? Okay, we've talked about what it is. We've talked about how it's built. We're going to return now to why we've built all of these, and we're going to go through some use cases. So if you look at, we're going after the lean IT groups because that is the group that needs the most amount of simple to use tools, and they don't necessarily have the resources to go build a 7-vendor, 7-layer cake and do it well. So they need something that's very integrated and easy to use. You're already leveraging cellular. So maybe you already have a Cradlepoint in your environment that's talking to the public cellular network. You understand how it works, the intricacies and the efficiencies that you get from that. And you've got high density or high diversity connectivity. And we'll go through the use cases that, where Wi-Fi makes sense and where public cellular or private cellular might give you a new tool in the tool bag. And I won't spend too much time here, but it's important to know that this fits within the Cradlepoint ecosystem. So when we talk about lifecycle management, we apply the same principles to this new product area, a new solution area that we do with everything else that we build. And that is, it's easy to install, it's easy to manage, the software updates are there from a continuous perspective, and we've built in all of the licensing and management. So you don't have to go install a separate management device you just go through NetCloud Manager. I want to touch on this very, very, very quickly. I know a lot of you weren't as familiar with private cellular, but one of the things that trips up a lot of implementations or installations is you may go build that 7-layer cake from 7 different vendors, and then you've got to add an 8th layer that says, I'm using public spectrum, so I've got to go communicate with a broker, and that's called the SAS, or the Spectrum Access Service System. And a few companies provide that, Federated, Google, and if you're doing this on your own, you have to go find your own account, you have to communicate with this system on your own. But with Cradlepoint, we bundle that into the solution. So it's already there as part of the solution. All you do is, again, the single pane of glass, single pane of glass. Ooh, dry throat. Chris, you want to talk about this?
Sure. I'm Chris Peters with Cradlepoint. So the network planning tool that we have integrated, and we think this is an extreme value add. So James talked about the 7 different systems. The systems that are out there today don't include this. We include this as part of our tool. This is a network planning tool. If any of you are familiar with ever doing RF planning for a Wi-Fi network, very similar, except obviously geared towards cellular network RF planning. It's really easy. It comes integrated with our tool. You can drag and drop a few things, kind of spell your layout. You see here, we've got an office. So makes it really easy. Again, we're looking at lean IT operations, right? Where you don't have an RF planning team, most likely. So this makes it really easy. And honestly, we believe that this is a real game changer for private cellular network.
Yeah, thank you, Chris.
Yeah.
Apologize for that. So this makes it really, really easy to go into that warehouse or open air park if you're a public safety or public sector customer and design how many access points do I really need. You don't have to put up 10 and see if 2 will work. You get to design it beforehand. So this allows you to do a lot of the pre-planning without the complexity. Now I won't go into too much detail because I wanted to jump to, this is what the access points look like, the cellular access points that we talked about. We have one that works in indoor, one that works outdoor. So you can see they look an awful lot like the Wi-Fi access points that you've seen before. These are the endpoints. We have a couple of them on the table downstairs, but very, very similar to that all-in-one approach that gives you the Ethernet ports, the Wi-Fi to connect to devices that only can connect via Wi-Fi. And then all of these have the ability to hop on that private cellular network that you've now built. Same here on the adapter side. I'm sure you're all going to run out and order this today. So this is what you got it. No, I'm kidding. Let's get to the use cases real quick. I think we got a question. Yes.
The routers, they're also LTEs.
Yes.
Are there plans to move those up a little or?
From LTE, do you mean 5G? All of those that we saw. So let's go back real quick. So all of these here have the ability or have access, except with a couple of them, have access to a 5G model. Okay, so when I buy an E3000, I can buy one that is specifically LTE, or I can buy one that's 5G. And both of those versions can also do the private cellular.
And then, I apologize if you went through this or about to go through this, but the private cellular that you're planning to deploy, what technology would that be in? Would that be in the LTE range or?
So the easiest answer is yes. So it's going to be, you can do private cellular on LTE, 4G, and you can do private cellular on 5G.
And a little bit to add on to that is it's not an either or for our endpoints either. They're LTE and 5G.
Yes. So you can do just basically, we have a lot of customers that as their network is building out, they deploy 5G, but in areas where that public cellular carrier that they're working with, 5G is not available. It just operates on LTE until it's ready. And I think we have 2 minutes left, so let's go through a couple of the use cases. So industrial, we talked about this, utilities, mining, oil and gas. Think about big open areas, outdoor mining, quarries, things like that. Military installations, utility installations where I have big outdoor areas. It's very, very tough to cover with Wi-Fi, whether you have backhaul connectivity there with fiber, or if you even have power to do that. So now I can take a private cellular network that has a much broader coverage, and it's a little bit easier to deploy. I'm going to mention neutral host, and then we're going to fly right by it. What I want you to remember with neutral host, all that means is there is technology out there that once you build your private cellular, you can now share that, and with some of the right agreements, someone that's on Verizon could get to Verizon through your private cellular network. Okay, so that's
Without a private SIM.
without a private SIM. So that basically, if it takes, there's a lot of variables in there, but that's something that's coming in the future as more companies deploy private cellular. There may be an option, like I said, there's a lot of variables, but technically it's there that someone with Verizon could jump on your private cellular and get to Verizon through you. Okay, so that offers up a lot of flexibility from a use case perspective. Fixed wireless access. We work with a lot of companies that are doing distance education, that K-12 higher ed model, where they put out a private cellular network for their students that allow them a little bit easier and lower cost Wi-Fi access and backhaul to the internet versus which can sometimes be a very expensive public cellular solution. So we've had some school districts implement some of these private cellular networks to do that. If you want to go, some of the things that I want to pick out here, I would say logistics is probably where we're spending a lot of time. Video security with, think about smart cities, that I can deploy and control an infrastructure as a smart city with a little bit more efficiency than relying on public carriers to do it. Here we go. Here's the smart cities example. So you can have a lot fewer cellular access points than, say, Wi-Fi, and they become a lot easier to manage. We talked about the education one, but some of the challenges, some of the use case there is that you are allowed to use really your imagination when it comes to how can I get connectivity to my students in a more efficient manner. And this is just one strategy. Warehouse logistics, we do a lot here. I mentioned the forklift example, but we also have a few other examples where we have smart robots that are moving throughout a warehouse or logistics facility that have SIMs already on them, right? The manufacturer of that smart robot has built it in with SIMs. So you use a private SIM and they can have a direct relationship with the private cellular network that you built without having to have another endpoint, a physical endpoint on that device. So it can operate in both scenarios where the SIM doesn't necessarily have to go into a Cradlepoint device. The SIM can go into a tablet. The SIM can go into a phone. The SIM can go into an industrial piece of equipment that has the SIM stack, the cellular stack built into it. Large venue and hospitality, we're seeing a lot of this. The difference between IT and OT, you're going to hear a lot more of that in the industry. The idea that IT, I want to separate, let's say I operate a sports venue and I want to offer Wi-Fi to my guests, that I want to separate all of the devices that I use to all of the food and beverage. I want to split that and not try to get revenue generating pieces of equipment on the same network that I have the public Wi-Fi on. So this allows to create two networks and to separate that traffic so I can keep that revenue traffic up and operational at all costs. And I think this is our last slide. And I would say, what I want you to think about this is just across here. Private cellular networking, it's not easy, but in the same token, it's not hard anymore. Somewhere in the middle. So if you have some interest in some of the use cases that you're thinking about, find someone from Cradlepoint and say, hey, let's have a conversation. Would this be right? And I will leave you with this. Public cellular is not going away. Wi-Fi is not going away. Private cellular is just that mix in between that gives network builders another tool in the tool bag. Any questions?
Yes.
Yes.
Well, thank you for your presentation. So we've been looking at private networks for a while.
Yep.
And I've spoken to Amazon, AWS.
Yep.
Something. What separates you guys?
What separates? If you look at, I mean, Amazon, AWS, and we have a lot of partnership with them. So it's very similar in what they're doing. I think where we can differentiate is just our cellular knowledge, that it's already built into our products. Our company grew up on cellular. So whether it's public or private, we can offer you a little bit more flexibility from the solution perspective.
Amplifiers, yeah. Radios, right?
Mhm.
What would be, what would be out of
Well,
you
the
guys?
thing is, I don't know. Set up a place to back off. Figure out how to pin this.
That's a great question. So it really depends on the environment that you're going into. Think about a very busy warehouse where you have very tall stacks of stuff.
Right.
So depending on what that stuff is, sometimes cellular signals will go through that easier than others. So our rule of thumb that we use, and I mentioned earlier, is if it takes, let's say 12 APs, Wi-Fi APs, you can get away with one. But that has some variability depending on what material you're going through.
Yeah.
Yeah.
Just assuming no whatsoever. To that.
So the terminal is going at 248?
Yeah, let's see, let's go with this space.
Okay.
What would be the maximum? Because
It's the one that
I won't
87.
be used to
I see.
looking at use cases.
Yeah, go ahead, that is. I gotta take a train somewhere.
Next, IoT.
Right.
I woke up to the wrong time.
space. We don't want to lose our stuff. The wrong way.
2:30.
Right.
So, let's say we're trying to advance, trying to cover space.
Right.
But
Like
this is want to make sure that until we pick something on the end of the runway and something else on the other end of the runway, we just want to know how effective are those two nodes to be able to connect to each other.
So you're talking about putting one on either end of the runway?
Correct, yeah.
How long's the runway?
Well, we can have really long runways, but I'm just trying to get a picture.
I think if you, just from a general rule of thumb, because there's different APs, there's different power you can operate at. But I would say you're probably a good rule of thumb would be a couple thousand feet to a mile or two. I mean, it just depends. But it's not tens of feet, right? You're going to be hundreds,
Yeah,
thousands
that's
of feet, right?
what I'm saying.
Yeah. So it will cover a good chunk of distance.
All right.
Just like you said, unfortunately, there's too many variables. It depends answer, but yes, we're talking about thousands of feet, not hundreds of feet.
Yeah.
Yeah.
And when you've got line of sight and there's nothing in between, you can really stretch too.
Yes, exactly.
Yeah.
That's what I'm a little bit interested.
Well, I can tell you're a smart guy because you have a Navy veteran. So you're asking good.
Are you a U.S. Navy veteran as
I'm
well?
Navy,
But yeah.
But you have got a great use case. I mean, we're talking to a lot of airport networking systems. A big customer of ours is JBT on the, it was 11:30. I figured we're standing between them and lunch, so. But yeah, great question though.
Yeah, we'll